pendrive తీయొచ్చా? Okay, good morning. Today I'm going to explain you organ function test. Under that, first I would like to explain you LFT. LFT is liver function test. So before to understand this, what do you mean by LFT functional test means? These are a group of tests which will assess the normal functioning of the liver. Okay, LFT means here these are not a single test. These are a group of tests which will be performed to assess, to determine the normal functions of the liver. So before going to the test, just we should have an idea about what are the functions of the liver. Okay, so here we all know that liver plays an important role in metabolisms. Okay, it is the key organ in the metabolism of the carbohydrates, lipids, proteins. And liver is the organ where, and coming to the protein metabolism, liver is the major organ which help in the detoxification of ammonia into urea. Okay, ammonia is the end product of catabolism of amino acids. Okay, not end product, it may be formed in the degradation of the amino acid, but ammonia is toxic to the body. So that toxic ammonia is being converted to water soluble non-toxic compound urea. The conversion exclusively takes place in the liver, and it is the principal organ. Like if you take the cholesterol metabolism, it is synthesized in the liver, and its utilization, that is, even it is catabolized to form maybe other biological compounds like bile salts, bile acids, that happens in the liver. Okay, and even the cholesterol in the blood, it exists in either as free cholesterol or free cholesterol and cholesterol ester. So the esterification of cholesterol, even it takes place exclusively in the liver. Okay, now what we are discussing? So we are discussing about the metabolic functions of the liver. It plays an important role in all the three metabolisms: carbohydrates, lipids and proteins. Liver help in the conversion of ammonia to urea, and the cholesterol, it is synthesized and catabolized in the liver only, and even esterification of the cholesterol also occurs in the liver. And here even the here in the liver, monosaccharides after absorption, other than the end products of carbohydrate digestion, or glucose, galactose and fructose. Okay, other than glucose, the end products, okay, that is galactose and fructose, after absorption, they will be transported to the liver. There it will be metabolized to they will be converted to glucose. Okay, so that means the end products of the carbohydrate digestion, other than glucose, that is galactose and fructose, they will be transported to the liver. In the liver, they will be further metabolized and finally being converted to glucose. And here liver even help in the catabolism and anabolism of nucleic acids. Okay, it help synthetic reactions and catabolic reactions of nucleic acids may takes place in the liver, and even liver is involved in the metabolism of the vitamins and minerals to some extent. Okay, so liver plays a major role in the metabolism of not only carbohydrates, proteins, lipids and even to some extent, to certain extent, vitamins and minerals are also metabolized. So that is the metabolic capacity of the liver. Then coming to the other functions of the liver, secretory function. Liver is responsible for the formation of secretion of the bile. Okay, the bile which is formed in the liver, that will be temporarily stored in the gallbladder, and through common biliary duct it will be excreted into the small intestine. So this bile contain bile pigments, okay, and bilirubin, the bile pigment is bilirubin. And what is bilirubin? It is formed from the catabolism of the heme, okay, that gets conjugated in the liver and then secreted into the bile. Okay, so liver is responsible for formation and secretion of the bile, and bile is carrying conjugated bilirubin. Okay, that the conjugated bilirubin conjugation takes place in the liver, so that conjugated bilirubin then secreted into the bile. Okay, and the next one is excretory function. So certain endogenous, exogenous dyes, okay, like bromosulfate, BSP, that stands for bromosulfathalin, and rose Bengal dye. So these are the dyes which are injected intravenously. They may be exclusively excreted through the liver cells. So liver has a role in the metabolism, and it helps in the secretion of the bile pigments of the bile into the intestine, and it helps in the excretion of the exogenous dyes like bromosulfathalin dye, etc., through the liver cells. Then liver has synthetic capacity, okay, mainly blood clotting factors, especially factor 5, 7, like 10, and fibrinogen. These are all synthesized in the liver. Okay, blood clotting, liver plays an important role in the synthesis of the blood clotting factors, okay, especially the mentioned, okay, 5, 7, 10, and fibrinogens. Now here, even the conversion of the prothrombin to active thrombin, it takes place, or usually they may be synthesized as the inactive forms. Okay, those inactive prothrombin may be converted to thrombin, that in the presence of vitamin K. You know that vitamin K is carboxylation of the inactive forms, so that makes the blood coagulation factors active. So, and even liver is involved in the blood formation in embryo and in some abnormal states in adults. Okay, see here. So liver help in the synthesis of the blood clotting factors. And not only that, the plasma proteins, important plasma proteins are like total protein, means it's a combination of albumin and globulin. Okay, albumin constitutes more than 50% of your total proteins, right? See here, your blood may contain 100 different types of proteins, but important plasma proteins are only 2, that is albumin and globulin. Together is known as albumin with the globulin together gives us the concentration of the total proteins. Total protein concentration, you all know that is 6 to 8 gram per deciliter. Out of the 6 to 8, more than half is contributed by albumin. So where this albumin is synthesized, it is synthesized exclusively in the liver only. And I think you know the functions of the albumin, which maintains colloidal osmotic pressure, so that help in exchange of the fluids between intra and extracellular fluids. And not only that, okay, and many functions are there for albumin. It acts as a buffer, help in maintaining the acid base balance, etc. Okay, so liver help in the synthesis of blood clotting factors and plasma proteins, especially albumin. Then coming to the next function of the albumin, see here, even liver has a role in detoxification. Okay, detoxification means removal of toxic compounds or conversion of the toxic compounds into less toxic compounds. So especially the Kupffer cells of the liver, they may remove the foreign bodies from the blood by phagocytosis, and even liver help in the detoxicate the drugs and hormones. So all these the toxic compounds which enter into your body may be converted to less toxic compounds in the liver. Okay, and even liver has storage function. So excess of glucose, that is carbohydrate, if you excess of glucose, it may be stored in the form of glycogen, where glycogen is stored especially in the liver and muscle. So glycogen is the storage form of carbohydrate. It is stored in the liver, and even vitamin B12 and vitamin A, these are also stored in the liver. So here, so liver, these are all the major functions of the liver. Okay, and liver is an organ which is involved in the metabolism and independently involved in many other biochemical functions. So it is like called the chemical factory of our body, because not only the metabolism and many biochemical reactions has been taking place here in the liver. So it is referred to as chemical factory of our body, and the generating power of liver cell is tremendous. Okay, so these are all the functions of the liver. Okay, what are all the major functions of the liver? So the liver has metabolic capacity. It has a role in the metabolism of carbohydrate, protein and lipids, and it has synthetic capacity, helps in the synthesis of the albumin and blood clotting factor, and it has a role, it helps in the secretion of the bile from liver into the intestine, it's a secretion of the bile into the intestine, bile may carrying conjugated bilirubin, and it help in the excretion, it has a role in excretion, help in the excretion of the exogenous dyes, and it has a role in detoxification. Okay, removal of toxic compounds into, means conversion of the toxic compounds into less toxic compounds. Here for example, ammonia which is being formed in your body, that is toxic. Toxicity can be relieved by converting into urea. Reactions takes place in the liver, and even liver has the liver help in the storage of like vitamins like B12, vitamin A and glycogen, etc. Okay, these are all the functions, major functions being performed by the liver. Then coming to the function test, liver function test. So usually these are non-invasive methods of screening for the presence of liver dysfunction. Okay, these are all that why we have to do this liver function test means. So these are the tests which will screen the any abnormality of the liver. Okay, and the pattern of the lab test abnormality, okay, which allows the recognition of general type of disorder. Okay, these tests which help us to identify, recognize the disorder of the liver, and it is also help us to assess the severity of the disease. Okay, and occasionally allow the prediction of outcome. So these tests are useful in diagnosing the abnormality of the liver disorders, and also it will be useful in prognosis. Okay, to and even evaluate, so that means prognosis means here evaluate the response to treatment and adjustment treatment when necessary. So like that, see here for diagnosis and for prognosis, these liver function tests are useful. So that's what these are the importance of liver function tests. And then coming to the test, and many here these all the LFT, these liver function tests are classified based on the major function of the liver. See here, LFT, okay, it's not a single test, I mentioned already, it's a group of tests, and these group of tests are further classified, test itself classified based on the major function of the liver performed. So let us discuss about the classification of the LFT. The first one is the tests based on the secretory capacity. Okay, so under that, the secretory capacity of the liver can be assessed by estimation of serum bilirubin and urobilinogen and bile salts in the urine. Okay, see here, first one is, these are the group of the test. These tests will assess the which function of the liver, secretory function of the liver. So whether the liver secretory function is normal or abnormal can be determined by determining like serum bilirubin, estimating the bilirubins in the serum, and detect, okay, qualitative detection of urobilinogen and bile salts in the urine, right? And coming to the second one, test based on synthetic capacity, means these tests only gives us the information about whether the synthetic capacity of the liver is normal or abnormal. Okay, so test based on synthetic capacity, there are two tests are there: estimation of serum albumin and prothrombin time test. Okay, these two are the tests done to assess the synthetic capacity of the liver. Next, third one, test based on metabolic capacity. So metabolic capacity of the liver can be assessed by performing a simple test, that is galactose tolerance test. Okay, it is not glucose tolerance test, it is galactose. Okay, galactose tolerance test. Then coming to the next one, test based on detoxification capacity. Okay, the liver can able to detoxify the compounds, can be the capacity can be assessed by this test, that is hippuric acid test. Then coming to the next one, test based on drug metabolism. Okay, and even few drugs they can be metabolized completely in the liver, so the drug metabolic capacity can be assessed by these two tests: antipyrine breath test, and then next one is MEGX test. Okay, these are the two tests which will assess the which functioning of the liver, drug metabolic capacity of the liver. Then next one is test based on excretory capacity. Okay, excretory capacity of the liver means excretion, means liver help in the excretion of exogenous dyes, example especially bromosulfathalin. So excretory capacity of the liver can be assessed by bromosulfathalin test. And the lastly, we do estimate enzymes under LFT. Okay, the last one is estimation of serum enzymes. So examples are transaminase enzymes, ALT, that is alanine transaminase, AST, aspartate transaminase, these two are the transaminase enzymes, and ALP, alkaline phosphatase, and the next one GGT, that is gamma glutamyl transpeptidase, etc. Okay, and what is the significance, why we have to estimate these enzymes and why these estimation of these enzymes is included under LFT means because these enzymes are due to the wear and tear of the liver tissues, hepatic tissues, some amount of these enzymes may be released into the circulation. Okay, so due to the wear and tear of the hepatic tissues, some amount of these enzymes may be there in the blood, so those are considered as the normal values. Suppose if there is hepatic damage, okay, liver damage, so more of the from the damaged tissues, more of these enzymes which are there in the hepatic tissues will be released into the circulation. Okay, so their increased in the concentration of these enzymes may be suggestive, could be suggestive of liver dysfunction. Okay, why? Because why some amount may, these are the enzymes which may be there in the hepatic tissues. Due to wear and tear of the tissues, some amount daily will be released into the blood circulation, so those levels are considered as the normal values. So if in liver damage, okay, due to the damage of the hepatic tissues, more of these enzymes, okay, these enzymes which are there in the hepatic tissues will be released into the blood circulation, thereby its concentration is increasing in the blood. So increased concentration of these enzymes especially could be could be indication of the liver dysfunction. Okay, so like that liver LFTs can be classified into different types. Okay, what are the how the LFT how the liver function test has been classified based on the major functioning of the liver. So major functions of the liver already we have discussed. It has a role in the secretion of the bilirubin, it has a synthetic capacity, it has metabolic capacity, it helps in the excretion, and it has a role in the drug metabolism, and it has detoxification capacity. So there are the few tests are there which will assess the secretory capacity of the liver, that is estimation of the serum bilirubin, urobilinogen and bile salts in the urine, and synthetic capacity can be assessed by estimation of serum albumin and prothrombin time test. Next, metabolic capacity can be assessed by which test? Galactose tolerance test. And detoxification capacity can be assessed by this hippuric acid test. Drug metabolic capacity of the liver can be assessed by these two tests, MEGX test and antipyrine breath test. And next, excretory capacity of the liver can be assessed by this bromosulfatolin test. And the next one is serum enzyme, estimation of the serum enzyme. Now coming to each class in detail, first let us discuss about the tests based on the secretory capacity of the liver. Under that you will be having this, okay, estimation of serum bilirubin, icteric index, urine bilirubin, okay, bilirubin, presence of bilirubin in the urine, and urine and fecal urobilinogen. Okay, all these are the tests which will assess the secretory capacity of the liver. First, coming to the serum bilirubin estimation, quantitative estimation of the serum bilirubin. How much of the bilirubin is there in the serum? That is quantitative estimation. Generally, we do this test by Vandenberg test. Okay. Now here, before going to the test, let me remind you the like bilirubin. What is bilirubin? Our normal lifespan of RBCs is 120 days. After that, RBCs are ruptured and there is release of hemoglobin into the blood circulation. So that hemoglobin, as it is a conjugated protein, it will be cleaved into protein part globin and non-protein part heme. And this globin, as it is further cleaved into amino acids, they will be enter into the amino acid pool and reutilized. Now, what is the fate of this heme? The iron which is there in the heme. Okay, please, if you remember the structure of the heme, there is porphyrin ring is there. Okay, at the center there is iron. In which form iron is there? In Fe+2 form. So, from the heme, iron will be released through in the form of transferrin. It is transported to erythroblast. Now here heme without iron, that undergoes further catabolism by, already you know the steps of degradation of the heme. So by heme oxygenase it will be converted to biliverdin, and biliverdin is further reduced to bilirubin. Okay, now here what is this bilirubin? This bilirubin we can call it as free bilirubin or indirect bilirubin, or we can call it as unconjugated bilirubin. Okay, now here when this bilirubin heme is catabolized in the liver, it is degraded. Heme is catabolized by the enzyme heme oxygenase. It is degraded into biliverdin and then to bilirubin. So this bilirubin is called unconjugated or free bilirubin. Now this free bilirubin is insoluble in water. So along with the albumin, it will be transported to liver. In the liver, what happened? This unconjugated bilirubin is then conjugated to conjugated bilirubin. That is nothing but bilirubin glucuronide. I think you know the step here. Bilirubin, it may be conjugate with the UDP glucuronic acid, two molecules of UDP glucuronic acid, and to form conjugated bilirubin. The chemical name for conjugated bilirubin is bilirubin glucuronide. Okay, now what is the role of the liver in bilirubin metabolism? Unconjugated bilirubin, which is formed from the degradation of the heme, is converted to conjugated bilirubin in the liver. Now this conjugated bilirubin is soluble in water, right? Through bile, it will be excreted into the small intestine. In the small intestine, what happened? Okay, see here, this is the in the like hemolysis here, which will gives rise to, which will be heme will be degraded to unconjugated bilirubin. Along with the albumin, it will be transported to the liver. In the liver, what happened? This only albumin gets separated before only unconjugated bilirubin enters into the hepatocytes. Because why albumin binds to this? In order to transport insoluble unconjugated bilirubin from blood to the to the liver. Now, unconjugated bilirubin in the liver, it may gets conjugated with the glucuronic acid to form conjugated bilirubin. Now, this conjugated bilirubin through bile, it will be enter into the small intestine. Okay, and now in the small intestine, this bacterial degradation, this bacterial proteases, which will further metabolize the conjugated bilirubin into urobilinogen. Urobilinogen, where it is being formed in the small intestine from the conjugated bilirubin. Now, 10% of this urobilinogen is enter into the portal vein, and to portal blood circulation it will be transported to the kidney, where and it is filtered, and then urobilinogen is excreted through urine. Okay, 10% of this will be reabsorbed from the small intestine, and through blood it is passed, it will be passed through the kidney and then excreted through urine. And the 90% of the urobilinogen is then converted to stercobilinogen, that will be excreted through feces. Okay, now here the normal color of the feces is due to because of the presence of stercobilinogen, and the normal color of the urine is due to the presence of urobilinogen. And what are this urobilinogen and stercobilinogen? These are derived from the conjugated bilirubin in the small intestine. So now here in the blood, there are two types of bilirubins we may found, that is unconjugated bilirubin and conjugated bilirubin, right? So conjugated plus unconjugated together gives the total bilirubin levels. Okay, total bilirubin means total. It's a combination of conjugated bilirubin plus unconjugated bilirubin levels. Now here, and these, okay, here already this explained you, and here then there is a total bilirubin means it's a combination of total bilirubin is equal to conjugated bilirubin plus unconjugated bilirubin. Unconjugated bilirubin, you can also call it as free bilirubin, okay, or indirect bilirubin. And conjugated bilirubin, conjugation where it happens in the liver, and the conjugated bilirubin, it is also known as direct bilirubin. Okay, if you see the difference between the free bilirubin, free is nothing but unconjugated or indirect bilirubin, conjugated or direct bilirubin. And if you see the differences, see here, free bilirubin, that is unconjugated bilirubin, is insoluble in water, whereas conjugated bilirubin is soluble in water. Okay, and this unconjugated bilirubin is soluble in organic solvents, and so as it is insoluble, it will be transported in the blood along with the albumin. What about the conjugated bilirubin? It is soluble in water alone, it can transport in the blood. And the normal plasma levels of this unconjugated bilirubin is 0.2 to 0.6 milligram per deciliter, whereas the conjugated bilirubin, almost as it is soluble, it is excreted through urine. Almost it may be catabolized into urobilinogen. So almost its concentration is 0 or 0 to 0.2 milligram per deciliter. Okay, why this concentration is less means conjugated bilirubin in the small intestine, it is further it is oxidized, it is further converted to urobilinogens, and you know the fate of urobilinogen. 10% may be excreted through urine, and 90% may be further converted to stercobilin, which will be excreted through urine. So that's what the concentration of conjugated bilirubin is, almost nil or to 0.2 milligram per deciliter. And unconjugated bilirubin is absent in the bile. Why it is absent in the bile? By the time in the liver, what happened? The unconjugated bilirubin, if liver functions normally, if it gets conjugated, so that's what there won't be means there is no unconjugated bilirubin in the bile. But bile contains which type of bilirubin? Conjugated bilirubin. And free bilirubin is completely absent in the urine. Even conjugated bilirubin also further metabolized, so it is also directly conjugated bilirubin or unconjugated bilirubin, they are absent in the urine. And free bilirubin is directly absorbed from the and small intestine, but conjugated bilirubins are not absorbed, and free bilirubins are freely diffuses into the tissues, whereas conjugated bilirubin does not diffuse into the tissues. Okay, try to note down the differences between the unconjugated and conjugated bilirubin, and this free bilirubin and unconjugated bilirubin can be estimated by a simple test, that is Vandenberg test. So type of the response for unconjugated bilirubin, it is indirect positive, and the type of the response for conjugated bilirubin is direct positive. Okay, these are the differences between unconjugated bilirubin and conjugated bilirubin. In the urine there won't be any type of bilirubins. Okay, in the bile only conjugated bilirubin is present. Free bilirubin, unconjugated bilirubin is insoluble in water, whereas conjugated bilirubin is soluble in water. And here this free unconjugated bilirubin diffused into the tissues, but conjugated bilirubin does not diffuse. The type of the response is free bilirubin. Unconjugated bilirubin gives indirect positive, whereas conjugated bilirubin gives direct positive. And coming to the normal total bilirubin levels, in normal healthy person, total bilirubin means combination of direct plus indirect. Direct is conjugated, indirect is unconjugated. So total bilirubin levels should be less than 1, almost 1, less than 1 milligram per deciliter. Okay, there is a range, minimum of 0.2, maximum of 1.2 milligram per deciliter. That is your total bilirubin levels. Out of this, normal means conjugated bilirubin concentration is 0 to 0.3 mg per dl, and the concentration of indirect, that is unconjugated bilirubin levels, is 0.2 to 0.9 milligram per deciliter. Okay, if the plasma bilirubin levels exceeds, normally total bilirubin level should be less than 1 mg per dl. If it is beyond, more than, exceeds 1 milligram per deciliter, that is known as hyperbilirubinemia. Hyperbilirubinemia is a term denotes or indicates the concentration of total bilirubin level is more than 1 milligram per deciliter. If the levels of the total bilirubin levels are in between 1 and 2, that is an indicative of latent jaundice. Okay, if the bilirubin levels exceeds more than, exceeds 2 milligram per deciliter, it diffuses, then excess is diffused into the tissues, producing yellowish discoloration of the sclera, conjunctiva, skin and mucous membrane, resulting in jaundice. Okay, see here, normal total bilirubin level should be less than 1 mg per dl. If it exceeds, if it is in between 1 to 2, that is not jaundice, that we can call it as hyperbilirubinemia. And if the level is more than, level of which total bilirubin is more than 2 milligram per deciliter, then that is known as that causes jaundice. So jaundice is characterized by yellowish discoloration of the eyes. Okay, why yellow? The sclera becomes yellow means because excess of the bilirubin gets deposited in the sclera, that gives yellowish discoloration, and conjunctiva, and if it gets deposited under the skin becomes yellow in color, and there is excretion of the bilirubin through the urine. So jaundice is characterized like it is characterized by passing of the dark yellow colored urine. Okay, and these are the characteristic features of the jaundice. Now here there is isolated unconjugated hyperbilirubinemia. Okay, that means here this is the indirect bilirubin fraction. Sometimes it is greater than 85% of the total bilirubin. So that means, okay, sometimes only unconjugated bilirubin levels are increased. In which condition unconjugated bilirubin, here the conjugated bilirubin levels are normal, but unconjugated bilirubin levels are increased in your blood circulation. Obviously, if one parameter is increased means there will be increase of the total bilirubin levels. So which conditions increases the unconjugated bilirubins means hemolysis, excess breakdown of the RBCs. So breakdown of the RBCs increasing the production of unconjugated bilirubin levels. Then ineffective erythropoiesis. okay, and the drugs like rifampicin, and okay, resolution of the hematoma. So in all these conditions there is increase of hyper, which bilirubin levels are increased, unconjugated bilirubin levels are increased. Okay, so these are all the conditions where there is increased production, that means increased formation of the unconjugated bilirubin, and sometimes there is defects in hepatic uptake and conjugation. Okay, see here, now what we are discussing, there is some conditions which leads to increased levels of unconjugated bilirubins. Increased levels of unconjugated bilirubin is known as unconjugated hyperbilirubinemia. Okay, so what are all the what are the causes for this unconjugated hyperbilirubinemia? Means maybe due to increased production or due to defects in the hepatic uptake or its conjugation. Increased production may be seen maybe in the hemolysis, ineffective erythropoiesis, and the usage of the drugs like rifampicin, and the resolution of the hematoma. And if there is a defect in the hepatic uptake, actually what is the fate of unconjugated bilirubin? Along with the albumin, it will be transported to the liver. There in the liver, what happens? This unconjugated bilirubin is conjugated to conjugated bilirubin. But here there is a syndrome, Gilbert syndrome or Crigler-Najjar syndrome. Already this we have discussed in the heme metabolism. Because of this, there is defect in the uptake of the unconjugated bilirubin. Okay, or if there is any defect in the conjugation. Okay, so one enzyme is there, glucuronide transferase enzyme is there. Suppose if that enzyme is defect, what will happen? Unconjugated could not be converted to conjugate. That would leads to increased bilirubin levels. Okay, so unconjugated bilirubin levels only increased in your blood, so that is known as unconjugated hyperbilirubinemia. Please make a note here, conjugated bilirubin levels are normal, and there is increase of unconjugated bilirubin levels, and there is increase of total bilirubin levels, maybe due to increased production or due to like in Gilbert syndrome and Crigler-Najjar syndrome, there is defect in the uptake of the unconjugated bilirubin, or if there is any abnormality in the conjugation. Then coming to the next one, conjugated hyperbilirubinemia, means here in this condition there is increase of conjugated bilirubin levels. So here conjugated bilirubin is nothing but direct bilirubin. Here the direct bilirubin is greater than 50% of the total bilirubin. Now already you know that conjugated bilirubin cannot differentiate obstruction and parenchymal disease, and and it may be seen in delta fraction. Especially here the conjugated bilirubin is in this fraction, this conjugated bilirubin is tightly bound to the albumin. Okay, and there is a tendency of hyperbilirubinemia to resolve more slowly than the biochemical test. Okay, now here then coming to the classification of the jaundice. Okay, now here till now we have discussed about the jaundice metabolism of bilirubin. Bilirubin is the end product. Bilirubin is formed during the degradation of the heme, and there is total bilirubin. It's a combination of conjugated and unconjugated. So here if the total bilirubin level is more than 2 milligram per deciliter, so that is known as that is resulting in jaundice. And there are 3 types of jaundices are there. Okay, the jaundices are classified as, so any type of the jaundice, what is the common feature? The total bilirubin levels more than exceeds 2 mg per dl. Okay, total bilirubin levels are elevated. That is the common feature seen in the jaundice, any type of jaundice. But the jaundices are of 3 types classified into, that is pre-hepatic jaundice, hepatic jaundice, and post-hepatic jaundice. Pre-hepatic jaundice is also known as hemolytic jaundice, hepatic or hepatocellular jaundice, post-hepatic or obstructive jaundice. Now jaundice, 3 types of jaundice. Okay, jaundice is classified into 3 types: hemolytic, hepatic, and obstructive. Okay, and here in hemolytic jaundice, what are the causes of hemolytic jaundice? Abnormal red cell antibodies drugs which increases the breakdown of the RBCs, toxins, thalassemia, hemoglobinopathies, and Gilbert syndrome and Crigler-Najjar syndrome. In all these conditions, there is excess breakdown of the RBCs, hemolysis. Because of excess hemolysis, what will happen? There is increased production of unconjugated. Okay, hemolysis means RBC breakdown, increase the availability of the heme. Heme is further degraded to form unconjugated bilirubin levels beyond the capacity of the liver to conjugate. Liver has some capacity to conjugate the unconjugated. Okay, liver has some capacity is there to conjugate the bilirubin. But here, because of the increased breakdown of the RBCs, there is increased production of unconjugated bilirubin levels, that is over beyond the capacity of the liver to conjugate. So that's what in hemolytic jaundice, which type of bilirubin levels are increased? Unconjugated bilirubin levels are increased. So these are the conditions which causes increased, means which increases the hemolysis. Then coming to here, so here in the hemolytic jaundice, unconjugated bilirubin levels are increased and total bilirubin levels are also increased. Now here coming to the hepatocellular jaundice, here this may be due to viral hepatitis, toxic hepatitis, or intrahepatic cholestasis. Okay, these are all the causes which could cause which will damage the liver tissue. So that's what there is increase of in hepatic jaundice. Please make a note, there is increase of both unconjugated and conjugated bilirubin levels. Both will be increased because of the hepatic damage. What will happen? More of unconjugated bilirubin could not be conjugated, so increased unconjugated bilirubins. And even the conjugated bilirubin also, because of the inflammation of the hepatic blood vessels, so they could not secrete into the bile, they could not enter. Okay, so that's what, even there is increase of the conjugated bilirubin. Please make a note here, in the hepatic jaundice, because of these are the causes for this hepatic jaundice, it is characterized by increase of both unconjugated and conjugated bilirubin levels. Then coming to the obstructive jaundice, third type of jaundice is obstructive, that is post-hepatic. Now here liver is functioning normally, but still there is increase of the bilirubin levels because there is obstruction in the common biliary duct. Okay, that means bile which will excrete from the liver through to the small intestine through common biliary duct. If there is obstruction in the common biliary duct, or tumors of the bile duct, or the presence of gallstones prevents the free flow of the bile, and carcinoma of the pancreas, lymph node enlargement, and even in the extrahepatic cholestasis. In all the condition, there is obstruction in the free flow of the bile which is carrying conjugated bilirubin from where to where? From liver to small intestine. And because of this obstruction, which bilirubin levels are increased? Conjugated bilirubin levels are increased. Okay, now here in the liver is functioning normally, where here in pre-hepatic and post-hepatic, but still there is jaundice because in pre-hepatic due to excess breakdown of the RBCs, anyway in hepatic due to liver damage only, but in post-hepatic due to the obstruction in the bile flow, still there is increase in the total bilirubin levels. So in all these three types of jaundice, there is increase of the total bilirubin levels, but in hemolytic jaundice total will be increased because of increase of unconjugated bilirubin. In hepatic, total bilirubin levels increased due to increase of both unconjugated and conjugated. And in the obstructive jaundice also, there is increase of the total bilirubin levels due to increase of only conjugated bilirubin levels. Okay, like that, these are the three classes of the jaundice. Now coming to the Vandenberg test. Okay, this test will explain you tomorrow's class. Thank you.